Good day, everybody. I have two jokes for you today, and you can pick which one you like best. Um, and if you really feel the need, you could, in one of your assignments, tell me which one you like the best. So, what do you call an indecisive bee? Indecisive bee, a maybe. Or, where do bees go to the bathroom? The BP station. The BP station. So you can pick, is it a maybe or BP station, whichever one you like better. Okay, so today, geometric probabilities. Tomorrow, a little more geometric probabilities. Thursday, um, project, no final exam, final project, and then you'll get that handed in and be good to go. What are geometric probabilities? Well, before we do that, we have to talk about general probabilities. Okay, so just in general, probabilities are a number between 0 and 1. And I'm just going to quickly review this because we did this way back in first trimester, but it's not too bad, even if you weren't with me, because some of you are joining, or a couple of you are joining late. What I mean by that is you weren't with us first try. Probabilities are a number between 0 and 1, and they tell about the chance of something happening. So I got one die here. All right, I'm going to say probability roll a 1. And as you can see, that right there is a 1 that I rolled. It's the top number is my 1 right there. So probability roll 1. Well, here's how probability works. You take your number of successes over your total number of possibilities. That's how you do every single probability problem, every single one. So how am I successful? Well, there's only one way to be successful. That's if I roll a 1. How many different ways can I roll a die? 6 different ways. Okay, 6 different ways. Let's go again. Probability roll a 5. Well, successes, how many 5s are there on the die? 1. How many total ways to roll? 6. Okay. Probability that I roll a 2 or a 6. 2 or 6. Now, or in the probability world means to add. Or means to add. So I take a 2. How many 2s are there? 1. Or means add. How many 6s are there? 1. That's over 6. So that's 2/6 of a chance. You're welcome to reduce it to 1/3, but you don't have to. It does not matter. Probably that I roll an even. Okay, well, probably roll an even. How many evens are there? 2, 4, and 6. There's 3 evens out of the 6 total chances. Okay. Probability that I don't roll a 3. Probability that I don't roll a 3. So I shake that die. Pretty good chance I'm not going to roll a 3. And actually, there's 5 ways that I can't roll a 3. Because I could roll a 1, a 2, a 4, 5, or 6. Any of those ways will get the success that I want out of the 6 total ways. So as you can see, that's how probabilities work. I'll start with the die. Now let's turn into geometric probabilities. Okay. Tori is going to join us for this problem. Tori, if you're watching, welcome to your problem. So let's do some probabilities with this. Probability that the point is on TO. Okay. Now, what I mean by point is this. Let's say I throw my pen at this line and it hits that line somewhere on that line. Like there's a big funnel that brings it in. It could hit here, 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 here. It could hit anywhere along that line. Infinitely many spots that could hit along that line. What are the chances that my point, my landing spot, is going to be on TO? All right. Chances it'll be on TO. So successes over total. Now, because it's geometric, we're going to look at lengths here, okay? How many different lengths do I have? And that's a 3, by the way. That doesn't look very good. Okay. How many different ways can I be successful? Well, I got 3 inches. And you could just say these are all the inches. It doesn't really matter. Miles, right? Okay, so how many different ways can be successful? I have 3 inches of success, basically. And in total, I have 8 inches because they can only land on that line. Okay, it can only land on that line. Can't land anywhere else. Got 3 out of 8. Let's do another one. Probability that point is on, let's go RI. Okay, so 3, 4, and 1. That's supposed to be in inches there. Got a little fuzzy. Okay, point is on RI, segment RI. So RI is here. I have 1 inch of success out of the total 8 inches That's how you do those problems. Let's do another one. The probability, by the way, that little p means probability. I keep saying it. I didn't actually tell you. But when I say probability, that means probably the point is not on OR. Probably that is not on OR. Well, I need my successes. In here, these are not successes. All right, these are not successes in here. My successes are out here or over here. And you heard me say or. So out here or over here, those are my successes. I have 4 inches of success or the total 8 inches. So every single one of these problems will be out of 8 for a basic probability. High level probability that can change. Let's do one more. The probability that a point is on OR or, that was funny, OR, segment OR, or RI, Rhode Island. Okay. The point is either on OR or RI. So OR means to add. So I could be OR, I have 4 inches of success. RI, I have 1 inch of success over the total 8 inches. So there's a 5/8 chance of getting on OR or RI. So that's how you do geometric probabilities when you're looking at a visual outcome like that. There's one more type of probability that you should see. So you prepped for your worksheet. I need to draw a big spinner. Okay. So maybe you know what a spinner looks like from a game. I'll draw a big spinner. Okay. It's supposed to be a circle. Mine will not look like a circle, but you get the idea. So I'm going to draw it in the middle here. Let's make a 100-degree angle. Let's make a 30-degree angle, and let's make a 50-degree angle. Okay, so I'm just kind of making this up as I go. Let's go 80 degrees, and then let's break it up into 2 50s over here. Okay, so now we're set to do the problem, okay? And we have this spinner, like this arrow that goes out, and you're going to click that arrow, it's going to spin around, 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 and it's going to land somewhere. So let's say the probability that it lands in the 100-degree range, okay? So in that 100-degree sector, we call this thing a sector, that it would land in there. Well, how many degrees of success do I have? 100 degrees of success. Well, how many degrees are there in the whole circle? Well, some of you know, if we add them up, we go 100 plus 30 plus 50 is 180, plus 80 plus 50 plus 50 is 180, so 360 degrees of success, or of total. So remember, it's successful degrees over total degrees. Let's try another one. Probability that it lands in 30 degrees, right? In that 30-degree window right here. Okay, we're looking to see if it'll land in there. Well, I have successful 30 degrees of success out of the total 360 degrees. Notice how the bottom with these angles always going to be 360. Let's do another one. Probability that lands in, let's do 80 degrees or 50 degrees. Okay, 80 or 50. Okay, well, it could land here, that's good, or here, or here, or here. So notice the 80 or 50, I have 50s, 3 of them, and 80. So it could be here, or here, or here, or here. So I'm going to go 80 plus 50 plus 50 plus 50 divided by 360 because it was 80 or 50. And since there's 3 of them, you got to add them all. Okay, so that would be 150, 230 out of 360. And again, you don't have to reduce those. They're completely fine as is. Last one, probability that it does not land in the 100. Probability that it does not land in 100. Well, that means my successes are all the rest, right? So that means that if I added all those up, I'd have 260 because it's that it doesn't land here, right? So probably I don't want it to land in the 100, which means I want to land somewhere over here. 50, 50, 80, 180 plus 50, 230 plus 30, 260 out of the total 360. So when you're working with degrees, the bottom's always 360, or means plus, not would be everything else. And when you are doing a line, it is looking at the total length. So notice when we're working with a line, your total lengths are always going to be the total length of the line. the top you have to figure out from what you were looking at. Okay, now that you watched this video, congratulations. You have one video to go tomorrow. So don't get all teary-eyed on me. I know some of you are going to really miss my presentations because they're that amazing. You'll survive. All right. Have a great day. Stay warm. Cold. Bye.